Number 5 has a 65 kilogram box pulled across the surface with friction. The box is pulled with 480 newtons of tension force. I can annotate that as FT. And 50 newtons of friction force. I can annotate that as friction force. And in the problem, I'm being asked to find the acceleration of the box, and that I can ignore any forces in the vertical direction. Now, the reason for that, the reason that I am able to ignore vertical forces is because the only movement is along the horizontal direction. So we don't have to include vertical forces because in that direction, that's not the direction that the acceleration is happening in. So when I use Newton's second law, which is printed right here for us, and by the way, if you can memorize it, that's awesome, but just remember that you have the cover page to help you. So when I apply Newton's second law, I have to make sure I focus it on either the horizontal or vertical direction. Now, with the problems that you're going to see, we try to simplify it so that it's obvious which direction you should focus on. And like in this problem, there is even a hint that you can ignore them. In more complex physics problems, it may not be obvious. And so something like this hint of ignore vertical forces may not be given in physics classes later on. So the strategy here is to use this equation and plug in what I know to figure out what I don't know. So if I'm being asked for acceleration, this equation is going to be useful. I can show a process. So using A equals, the acceleration is equal to the sum of forces divided by the mass. On the top part, I can write an expression that represents the total forces acting only in the horizontal direction. So with this green, with this blue marker, I'm going to show what direction the horizontal direction is. That direction, anything going left and right. Now notice on this part of the equation that I have tension force minus friction force. Just like the last problem, friction force is being subtracted from the tension force because friction force is going against the tension force. Friction force is going the negative direction. Remember when we studied motion, anything going to the right was positive. So when I take the sum of forces, which is what Newton's second law says I should do, it's going to be depending on which direction it's going. I'm adding up forces, but taking into account which one's positive and which one's negative. So from here, I can start to plug in numbers. Actually, before I do that, I'm going to add numbers in my diagram. In my diagram, I can represent the numbers that were given in the word problem, where 480 is how much is being pulled to the right, and 50 newtons is how much is being pulled against it to the left. So to complete my answer, I would first need to find what number I get for the total force, 480 minus 50, and divide that by the mass of the box, which I already annotated in the problem, is over here. 480 minus 50 will give me 430, and I divide that by the mass to get my final answer. The answer using these numbers will be 5.7 meters per second squared. To summarize the process, I took the information that was in the problem and used it to visualize which forces are causing the object to accelerate or change velocity in the x direction. With those numbers, with that visualization, I can apply Newton's second law, the equation, and plug in the total force by subtracting tension, force, and friction, and divide it by the mass in order to find out acceleration. You want to make sure that you are being careful and using precision when calculating the numbers. You can practice on your phone with the calculator, but keep in mind that on the test, you won't be able to use your phone as a calculator. You'll need to bring in your own calculator that you use in your math class, or you can borrow one from the class set, but there aren't going to be enough for everyone, so please bring your own calculator. On your own, read and annotate number 6 in your study guide. Your number 6 might be different than this number 6 up here. You can do the one on your paper and compare the process to the answer you're going to see. Or you can write this one down on a separate sheet of paper and try it out. Now for the answer. In this number 7, or number 6, there's a 70 kilogram skydiver that jumps out of an airplane and is speeding towards the ground without any air resistance. In part A, it asks, what is the weight or force of gravity on the skydiver? Hopefully this is starting to feel familiar, and we can all see that when we're asked for weight, it's asking for force of gravity, and this is the equation. To find out how much weight something has, how much the Earth is pulling on the object, or in this case a person, we take the mass and multiply it by the number 10, which represents the strength of gravity on Earth. For every 1 kilogram of mass, the Earth pulls 10 newtons. So for something that has 70 kilograms of mass, the Earth will pull with a force of 700 newtons. And according to the force diagram and the written description, they're jumping out of an airplane. There's no air resistance, so the only force acting on the person, on the skydiver, is the force of gravity. There's only one force. This is different than the other problems we've seen, where there's two forces going against each other. So to do part B, my strategy, the tool that's going to be really helpful, is Newton's second law equation. And remember, there's two versions. This one is helpful for when I'm trying to find acceleration. I use the other version when I'm trying to find a force. So here, on the top part of Newton's second law, this symbol represents sum of forces. And since there's only one, and it's going in the negative direction, I might label it like this. Now here, if you, one detail that I want to point out is this negative sign. It can be difficult to remember to put that negative sign. I want you to be mindful of it. That's what it means to do physics really well, is to pay attention to what direction like things like forces are pointed in. And usually we use down as negative. However, if you didn't have the negative here, you'd still be showing the right process, but it just wouldn't have the details needed to show that you really master physics. So here on the top part, I can plug in the number 700 because that's the force of gravity and it's in the negative direction, and divide that by the mass, which according to the problem is 70. The final answer would be negative 700 divided by 70. I can use my calculator if I'm not sure what it is. In my head, the final answer, will be negative 10 meters per second squared. So when this skydiver is falling and no air resistance, it's falling due to gravity, it's going to fall with an acceleration of negative 10 meters per second squared. That means every second that passes, it's going to get faster downward by 10 meters per second each second. It turns out all objects that fall, whether it's a massive object, a really massive object like a bowling ball, or if it's as light as a feather, we're going to see those two objects fall at the same rate as long as there's no air resistance. And that rate on Earth is about 10 meters per second squared in the negative direction. Now you're going to have some time to move on to number 7 on your paper. Again, if you want to do number 7 on your paper or the one that's up here, you could do it on a separate sheet so that you're overall practicing using mathematical thinking to describe interactions. So you're using math to find acceleration or to find force. In number 7, this is an example of how we can use Newton's second law or all of Newton's laws to solve for acceleration and force at the same time. So here's the answer for number 7. Use a different color. Okay, so number 7. A few moments after the 70 kilograms, so this is the same skydiver, 70 kilograms. Skydiver jumps, she reaches constant velocity of 200 meters per second due to air resistance. So now there is air resistance. I could tell from the force diagram that this represents the air resistance. Find the acceleration of the skydiver. I think this is a trick question. It's weird, I don't usually ask trick questions. Well, this is saying it's moving with constant velocity. And something we need to remember as physicists trying to understand how the world works is that acceleration means change in velocity. And if the problem says that there's constant velocity, that means there's no acceleration. So the answer here is 0. Part B, how much normal force? This is asking me, so similar to one we saw before, it's asking me for a specific amount of force. And in this case, I'm going to highlight it in yellow. It's asking for this force over here. Not the total force, but the normal force. If the acceleration is 0, that means there's no change in velocity. And if there's no change in velocity, that means the forces are balanced. That's Newton's first law, that if the forces are balanced, then that means constant velocity. And if the forces are balanced, that means however much is pulling down on the object is the same amount pulling up. And if I can find out how much is pulling down, then that's going to match the amount that's pulling up. So I can write that as Fn is equal to Fg because the forces are balanced. So Fn, the normal force from the air, is going to be equal to whatever the force of gravity is, which I remember from my toolkit, my tool belt, is this equation. I multiply the mass times g on Earth is 10. If the mass, and we did this in the last part, but the mass is 70, and I multiply that by 10, the normal force should be 700 newtons. So if something is falling with constant velocity, it doesn't even matter what velocity that is. Notice that I even had on here, I gave you a specific number. That you don't even need to use that number. So I'm being a little sneaky here. This number, it doesn't get involved in our equations. It doesn't get involved in our mathematical thinking because it only shows the velocity, and in order to find force, we need acceleration. And in this problem, it's not changing velocity, it's staying the same velocity, so there's no acceleration. Now it's time for you to try number 8. You can do this on your page or on a separate sheet of paper.